Roughly 85% of all the matter in the universe is invisible. You cannot see it, touch it, or shine a light on it. It emits nothing, reflects nothing, absorbs nothing, and yet it is supposedly everywhere, threaded through every galaxy, holding the cosmos together like an unseen skeleton. Scientists call it dark matter. It is one of the biggest open questions in all of physics. And here is the strange part. A team of astronomers has just found a galaxy that appears to contain none of it. Not a little, none. And it is not the first one they have found. It is the third. And the way these three galaxies are arranged in the sky is so bizarre that it might just tell us what dark matter actually is. Let me give you one number that shows how strange this is. The galaxy is called DF9. When astronomers measured its total mass, they got about 100 million suns. That figure matches the visible stuff inside it almost perfectly. The stars, the gas, the dust, nothing left over. But if this galaxy behaved like nearly every other galaxy we have ever studied, its true mass should have been more than 10 billion suns. 10 billion versus 100 million. That is roughly 100 times heavier. All of that missing weight is supposed to be dark matter. And in DF9, it simply is not there. So where did it go? Or was it ever there at all? Hold that question, because the answer is stranger than the absence itself. First, we need to talk about what dark matter even is, and why astronomers are so certain it exists in the first place. Because you might be thinking, maybe they're just wrong about the whole thing. Maybe dark matter is a mistake. That is a completely reasonable suspicion, and for a long time it was taken seriously. So let us go back to where this all started. Rewind to the 1970s. An astronomer named Vera Rubin was studying how galaxies spin. Now, a spiral galaxy is a giant disk of stars rotating around a bright, dense center. And there is a simple rule that should apply here, the same rule that governs our own solar system. In the solar system, planets close to the sun move fast, and planets far from the sun move slowly. Mercury races around, Neptune crawls. That happens because almost all the mass, the sun itself, is concentrated in the middle, and gravity weakens with distance. So the further out you go, the slower things should orbit. Rubin expected galaxies to work the same way. Stars near the bright center should whip around quickly, and stars out at the faint edges should lag far behind. That is not what she found. Instead, the stars at the outer edges of galaxies were moving just as fast as the stars near the center. It was as if Neptune were racing around the sun at the same speed as Mercury. By every law of gravity we understood, those outer stars were moving so fast they should have been flung out into empty space entirely. The visible galaxy simply did not have enough mass to hold on to them, and yet there they were, held firmly in place, orbiting at impossible speeds. Something was gripping them, something with a lot of mass, something we could not see. That invisible something is what we now call dark matter. Rubin's work, building on hints from earlier astronomers, provided the first really convincing evidence that galaxies are embedded in vast, invisible reservoirs of mass, far larger than the glowing part we can actually observe. And here is the mental image that matters. The bright spiral you see in a photograph of a galaxy is not the whole galaxy. It is more like the tip of an iceberg. Surrounding it, engulfing it, is a huge invisible sphere of dark matter. Astronomers call this sphere a halo. The visible stars are just the glowing core sitting inside a much bigger dark cocoon. Now, that alone might not convince you. Maybe our theory of gravity is just wrong at these scales. But the evidence kept piling up from completely different directions. One of the most beautiful pieces is called gravitational lensing. Einstein showed that mass bends space itself, and light passing through bent space follows a curved path. So when light from a distant galaxy passes by a huge mass on its way to us, that mass acts like a lens, warping and magnifying the light, sometimes smearing a background galaxy into rings or arcs. And when astronomers measure how strongly the light is bent, they can calculate how much mass is doing the bending. Over and over, the answer is the same. There is far more mass there than the visible matter can account for. The lensing sees the dark matter even though our eyes cannot. Put all of this together and you get the modern picture. Dark matter makes up around 85% of all the matter in the universe. Ordinary matter, the stuff of stars, planets, people, everything you have ever seen or touched, is a minority. We are the exception. The invisible stuff is the rule. And according to our leading model of how the universe is built, dark matter came first. In the early universe, dark matter clumped together into those halos, and those halos acted as gravitational scaffolding, pulling in ordinary gas, which then collapsed and lit up as stars. In other words, galaxies are supposed to form inside dark matter. The dark halo is the cradle. No cradle, no galaxy. That is the rule, which is exactly why DF9 is such a problem. Because DF9 is a galaxy with no cradle, and it gets worse for the theory because of what kind of galaxy DF9 is. It is a dwarf galaxy, small and faint. And under our standard model of cosmology, dwarf galaxies are supposed to be the most dark matter-dominated objects in the entire universe. The smaller and fainter a galaxy is, the higher the ratio of dark matter to ordinary matter should be. A tiny dwarf galaxy should be almost entirely dark matter with just a sprinkle of stars on top. So DF9 is not a mild exception. It is breaking the rule in exactly the place where the rule is supposed to be strongest. This is like finding a fish that has no water in the ocean around it. It should be impossible. So how did we get here? Let me tell you the story, because it did not happen all at once, and it was fiercely controversial. It starts in 2018. A team led by Yale astronomer Peter Van Dokkum published a paper about a faint, diffuse galaxy called DF2 in a distant group of galaxies, and DF2 looked wrong. Its stars were moving so slowly that the galaxy appeared to have little or no dark matter at all. The astronomy world was stunned, and honestly, a lot of astronomers did not believe it. A galaxy without dark matter contradicted decades of established theory. There were fierce arguments about the galaxy's distance, about the measurements, about whether the whole thing was a mistake. One galaxy without dark matter could easily be a fluke, a glitch, a bad measurement. But then, in 2019, the same team published another surprise. A second galaxy called DF4, sitting in the same little corner of space with the very same bizarre property, almost no dark matter. Now, two flukes in the same neighborhood is a lot harder to wave away. Something real was going on in that patch of sky. Then came the twist that turned a curiosity into a genuine mystery. In 2022, Van Dokkum and his colleagues, including a graduate student named Michael Keim, revealed that DF2 and DF4 were not alone and were not randomly placed. They were part of a chain. A straight, narrow line of faint galaxies strung across space like beads on a wire, roughly 10 of them in a nearly perfect row. And DF2 and DF4 were two links in that chain. That arrangement is not something that happens by accident. Galaxies do not naturally line up in tidy rows. Something must have created that formation, and that raised an electrifying possibility. If two galaxies in the chain lacked dark matter, maybe the others did too. Maybe the whole chain shared a common, violent origin. Which brings us to DF9, and to the newest chapter. DF9 is another galaxy sitting along that same trail, but there is a funny wrinkle in its history. For a while, DF9 had been misidentified entirely. It had been cataloged as a supermassive black hole, not as a galaxy at all. It was Michael Keim, now a Yale PhD candidate working under Van Dokkum, who during his doctoral research realized that DF9 was actually a faint dwarf galaxy on the trail, and that it desperately needed to be measured properly. Because if DF9 also turned out to lack dark matter, it would transform two strange one-off cases into a pattern, and a pattern demands an explanation. But measuring DF9 was brutally difficult. These trail galaxies are ghostly, diffuse things. DF9 is up to 100 times fainter than DF2 and DF4, which were already so spread out that astronomers call them ultra-diffuse. Trying to measure the motion of stars inside something that faint is at the very edge of what current technology can do. You need an instrument specifically built to squeeze information out of the dimmest possible light. That instrument exists. It is called the Keck Cosmic Web Imager, mounted on the Keck Observatory in Hawaii, one of the largest telescopes on Earth. It is designed precisely to study faint, diffuse sources of light, exactly the kind of feeble glow that DF9 gives off. The team pointed it at DF9 and stared. They collected light for more than 10 hours across 2 nights in October of 2024. 10 hours of patiently gathering photons from a smudge of a galaxy 45 million light-years away. Now, here is the clever part. How you weigh a galaxy you can never touch, visit, or place on a scale. You watch how its stars move. Remember Vera Rubin? The speed at which stars orbit inside a galaxy is set by the total gravitational pull acting on them, which means it is set by all the mass present. Both the visible stars and any invisible dark matter pack in a heavy, unseen halo, and the stars are forced to move fast to stay in orbit. Take the dark matter away, and the stars move slowly, governed only by the modest gravity of the visible material. So the speed of the stars is a scale. It weighs everything, seen and unseen. By measuring how the starlight was stretched and shifted across different wavelengths, the team could read off exactly how fast those stars were moving, and from that, calculate the galaxy's total mass. The result was stark. DF9 has a mass of about 100 million suns, and that number matches the visible matter, the stars and gas, almost exactly. There is no extra weight, no hidden bulk, no room left for a dark halo. If DF9 contained the normal amount of dark matter that a galaxy its size should have, it would tip the scales at more than 10 billion suns, 100 times heavier. That mass is simply absent. As the lead author put it, this is the first time anyone has ever seen an entire line of galaxies lacking dark matter. Not one strange galaxy, a row of them. So now we have 3 confirmed galaxies with no dark matter, all sitting along the same narrow chain in the sky. And that arrangement, that straight line, is the key to the whole mystery, because it points directly at how these galaxies were born. And this is where the story stops being about an absence and starts being about a cosmic collision. Here is the leading explanation. Imagine, long ago, 2 ordinary galaxies, each wrapped in its own normal dark matter halo on a collision course. They slam into each other at enormous speed. Now here is the crucial physics. Dark matter barely interacts with anything, not even with itself. So when the 2 galaxies collide, the dark matter halos essentially pass straight through each other, like 2 ghosts walking through one another, and keep going. But the ordinary gas is different. Gas is sticky. When the gas clouds of the 2 galaxies smash together, they crash, compress, and pile up, getting stripped away from the dark matter entirely. The gas gets left behind while the dark matter sails onward, and that stripped-out gas, torn free of any dark halo, gets flung out in a long streamer. As it spreads along that streamer, it fragments, cools, and collapses into brand new galaxies. But these new galaxies are built from the leftover gas alone, the ordinary matter, with none of the dark matter that stayed behind with the original galaxies. And because the gas was flung out in a line, the new galaxies form in a line, a straight chain of faint galaxies, each one made of nothing but ordinary matter, which is precisely what we see. DF2, DF4, and DF9, beads on a wire, born from the same ancient crash. That is a beautiful, self-consistent story. But it is not even the most mind-bending part. Here is the twist that makes this discovery genuinely important, and it is completely counterintuitive. You would think that finding galaxies without dark matter would be bad news for the idea of dark matter. If some galaxies do not need it, maybe none of them do. Maybe dark matter was never real, and instead our theory of gravity is just wrong. That alternative idea actually exists. It is a family of theories often called modified gravity, where the rule is that there is no invisible substance at all. Gravity simply behaves differently on the vast scales of galaxies. For decades, this has been the main rival to dark matter, and DF9 may be the thing that breaks it. Because here is the logic. If gravity itself works differently, then that modified gravity should apply everywhere, to every galaxy without exception. You cannot have a galaxy that opts out of the laws of physics. Under modified gravity, even a galaxy like DF9 should show the telltale signs of extra-gravitational pull, an effect from all the surrounding matter that makes its stars move faster than ordinary matter alone would allow. But DF9 shows no such thing. Its stars move exactly as slowly as ordinary matter, and only ordinary matter would predict. It behaves as though dark matter is a real, physical substance, a substance that this particular galaxy happens to be missing, rather than a universal quirk of gravity that no galaxy could ever escape. Think about it this way. If dark matter is a physical stuff, then it makes perfect sense that a violent collision could tear it away from a galaxy, leaving a galaxy without it. Stuff can be separated. Stuff can be removed. But if the effect we call dark matter were really just a rule about how gravity works, then no galaxy could ever be without it, any more than a galaxy could be without the laws of mathematics. The very existence of a galaxy that lacks the effect proves the effect comes from a thing, not from a rule. As Van Dockum put it, the finding is compelling evidence that dark matter behaves as an actual physical substance and not merely the product of an alternative theory of gravity. And this test bites hardest exactly at the scale of tiny dwarf galaxies, which is where those rival theories have always been argued over most fiercely. So the galaxy with no dark matter turns out to be one of the strongest arguments that dark matter is real. The absence proves the substance. That is the paradox at the heart of this whole discovery. But do not think this ties everything up neatly, because it does not. DF9 still leaves us with deep, unresolved puzzles. Our standard model of cosmology insists that essentially all dwarf galaxies should be overwhelmingly dominated by dark matter, and yet here is a whole trail of dwarfs that are not. That is a genuine tension in the theory, one that still has to be explained. The collision scenario accounts for these particular oddballs, but it also means the universe is capable of producing entire families of galaxies that break the standard mold. How often does that happen? How many more of these dark, empty chains are hiding out there, waiting to be found? And there is more work to do on this very chain. The trail contains around 10 galaxies, but only 3 have had their masses properly measured, because the rest are so faint they sit right at the boundary of what any telescope can currently detect. If the theory is right, those other galaxies should be missing their dark matter too. Confirming that will take even more sensitive instruments and even longer nights of staring at the faintest smudges in the sky. Each one measured is another test, another chance for the whole story to hold together or fall apart. For now, though, one thing is clear. A faint smudge of a galaxy, once mistaken for a black hole, 45 million light-years away, has quietly become one of the most important objects in the search for the universe's greatest missing ingredient. It is a galaxy defined entirely by what it does not contain. And in that emptiness, astronomers may have found their strongest clue yet about the invisible stuff that makes up most of everything. The universe hid 85% of itself from us, and it turns out the best way to catch it may be to find the rare places where it forgot to show up at all.